All right, let's handle question number 1 under a timer. So the question here, again, the first thing we always want to do is read the question. So the question reads, determine the distance from the park's center to any point along this path. Okay, let me highlight that. Determine the distance from the park's center to any point along the path. Everybody, if we were to, draw this out or illustrate this, what are we talking about? If we're trying to talk about this circular park right here, circular park, and we're trying to find the distance from the center to any point along the path. What idea are we talking about, my party people? Yeah, that's the radius all the way. We are looking for the radius all the way. From the center to any point along the path, that is radius. That's the number one thing. Remember, my party people, it's always about, can we identify the goal of the problem? And if it's, contextualized or using words like from the center to any point, well, can we go ahead and interpret that correctly? And in this case, as radius. So now that we know we're looking for radius, look at how that can help us as we move forward. So here, let's read the information. A festival organizer designs a circular park where the entire length of the decorative path, so the entire length of this decorative path measures 28 pi units. Again, the entire length of the path around the park. My party people, what are we talking about there? If we say the entire path is decorated all the way around, if we're decorating the path going all the way around, exactly, we're talking about circumference. So that's how we know that the circumference or the number that they give us here, the 28 pi units, that's how we know that that is circumference. So now that we have this, we're good, because the question we have to ask ourselves now is this. I know I'm looking for the radius of the circle. I know the circumference of the circle. Is there a formula, or what is the formula that connects radius to circumference? What's that formula going to be, my party people? Circumference equals should give us 2 pi r. That's right. That's the formula that connects everything together. Circumference equals 2 pi r. And so what we'll do is we will replace the circumference with its actual value, which is 28 pi right here. And that's going to equal 2 pi r. My party people, are we good from here to get the radius by itself? Can we get the radius by itself from here? Oh yeah, we absolutely can, because we just did our last example was just like this. We know that we can divide both sides by the contents right there. The 2 pi, we can divide that on both sides. And once we do that, the pi's cancel out, the 2's cancel out. On the left side, the pi's cancel out. And the final question is, what's 28 divided by 2? And there we go. The correct answer here will be 14 units. That is the radius of this park. And there we go. The correct answer here will be A. So, first question was a tough one. First one was a tough one where we had to work backwards immediately. But how did we feel about that one? Any comments, questions, suggestions? Go ahead, leave them in the chat box. See if you can get that question in there a little quickly. But we will move on here shortly to the next one. To answer the questions that I see, do we ever simplify? If we have a fraction as an answer, for sure, we'll always want to simplify with those. If they ever tell us to use 3.14 for pi, then we will plug that in and, clean things up with that. But we just go off of the directions that each individual problem gives us. And Louis, I'm glad that you're starting to see that you can work a little faster when it comes to dealing with circumference, because you know that the pi's are going to cancel out anyway. So you know that 28 is the diameter, cut that in half to get the radius, and you're good. So right on, Louis. And same thing with you, Corey. Same thing with you, Corey. You did the same exact thing. So you're showing that you're starting to get an advanced understanding of this, knowing where you can take some of these shortcuts. Right on. I like seeing that. So with that, let's go ahead and get into the next one here, my party people. Again, under a short timer here. If you're watching this as a recording, feel free to pause the problem and give it a shot on your own. You got this. All right, next on up, we're tackling this question here. And the question that we're answering is, how many miles did he run in total? Okay, so I know for a fact that for those of us that are refreshing and getting ready for, to take a test, we might be looking at these mixed numbers with, a little bit of side eye, right? Looking at them like, hey, I don't like these. What am I supposed to do with these? Add, subtract, multiply, divide. But some of us might just be seeing red, just because we're seeing mixed numbers and fractions. But let's take care of business in a nice gradual way. When we want to know how many of anything in total that we have, everybody, what's the first operation that might come to mind when we're thinking about getting a total? Yeah, addition. I think it's a natural response, right? Addition when we think about getting a total. So if we ignore the type of number that we're dealing with, if we just acknowledge that it's a number overall, not a fraction, not a mixed number, not a whole number, not a decimal, not anything, just a value. So here's what we have. Jake ran this many miles on Monday, this many miles on Tuesday. The total is just going to be adding these two values together. What's intimidating is that you're dealing with mixed numbers, but this problem is actually much easier than you might think. Let me show you. Everybody, if we have 2 1/4 plus 1 3/8, let me ask you this first. If we were to add mixed numbers, everybody, is it legal? Is it okay for me to add the whole numbers together? Can I just take the 2 and the 1 and add those together while I work on the other parts of the fractions? Yes, absolutely. Yeah, so let me take that 2 and the 1. Let me just go ahead and highlight them over here and then just show that I'm adding them right over here as 2 and 1. And that's going to give me 3. Okay, cool. So I have 3. And let me just be a little more graceful with that and just write the 3 right here with that box. Okay. Now, up next, what we have to really consider is just the 1/4 plus the 3/8. Now, everybody, before we freak out, answer this question first. To add or subtract fractions, we need the same what? We need the same denominator, yeah. So to get what 1/4 plus 3/8 will be, really what we need to begin with is, hey, let's get the same denominator so that we can talk about the fractions of the same size and therefore be able to add or subtract. So with that, everybody, what's convenient about 4 compared to 8? What do I have to do to 4 to get to 8? Yeah, multiply by 2. Now, I want you to be a little more clear, though, when you think about that thought. And I want you to think about multiplying by 2 on the numerator and denominator. Being very clear about that. Because, again, we don't want to make the mistake of leaving this as a 1. So be very careful. So if we multiply the numerator and denominator by 2, what we'll see is that we have 2/8 plus 3/8. And now that we have the same denominator, booyah, we can add these fractions together. Remember that we keep the denominator the same when we're adding fractions. And so we have 2 plus 3, and that's going to give us 5. So there we are. So allow me to highlight this again. We took care of this and this right over here. And now we have the 5/8. So our final answer, my party people, is going to be 3 5/8. Just like that. Again, not a crazy problem. The biggest pause might have been dealing with those mixed numbers. But if you focus on what we're supposed to be doing rather than the numbers that we're getting done, it can become a relatively easier problem, a much more calm process at that.